Okay, so let's do that, and then I'll do this. This will take about 10-15 minutes, so you guys want to write down some of these? Like, let's write down some of these. And then I'll let you guys work on 9 solutions if you need to finish that, and I will disclose the solutions today, and then you guys can work on your 30 NIEs. I have like 55 NIEs to do tonight. I cut 25 of them off. So I went down to 30, so just bear with me on that one, okay? Because the NIEs part is going to be very important when we get to pretty much every unit past this, because every unit has a reaction in it. So if you can't write the NIE reaction, it's just going to be like a little bit harder for you to kind of grasp the actual concept of that unit versus the NIE and the actual concept. So let's write these down. You guys write down what you want to, but I want to go through a couple of examples first. The first one's really easy. We actually probably did with this one yesterday. So go for it. Tell me what I'm writing. Uh-huh. What? HNO3 yields KNO3 and HOH. That's how I'm going to write it, as liquid. Okay, so right here, you're going to identify anything that's a soluble salt, a strong acid, or a strong base, and they ionize. If it's not one of those three, it cannot ionize. So, identify. Strong base, so it ionizes the K plus and OH minus. That's all. Yes, it is probably a weak base, but more specifically, it's a strong acid. Yes. Yeah. Nitric acid. Okay. H plus NO3, 1 minus. So when I say ionize, you're just breaking into the 2 ions, and then this one of the 3. We already have a strong base. We have a strong acid. This is a soluble salt, more specifically, right? Because it's a group 1A metal, so it's soluble, meaning it's going to ionize into the 2 components, and then we just have liquid water. Okay, so what are the spectator ions? Who are the spectator ions? Potassium ion and nitrate. So the NIE is OH minus plus H plus yields water, liquid. Okay, so if you can see that, and without writing the total NIE out, and then rewriting it as this yields this, I get it. Okay, you can do that, but you're going to mess up at some point in time. So just try to make sure you're paying attention. So I would rewrite that as OH minus plus H plus yields H2O. Next one, sodium hydroxide. Let's go quickly here. Plus what? HNO2 yields NaNO2, so sodium nitrite and H2OH water. Okay, it's balanced. Okay, so identify of the 3. Is this one of the 3? The 3 things that are soluble? Yes, strong base. So Na plus and OH minus. This one. It's not a strong acid, so it's a weak acid. And I like to label it up top to remind myself, especially right when I write it, if I realize it's not a strong acid, I write weak acid above it, and then it comes down. It does not change. It does not ionize appreciably, so we leave it as is. Yields what? We have a salt, right? Soluble or not? Soluble, because it's a group 1 metal, nitrite ion, and liquid water again. Okay, and it's just pure liquid. So what are the spectators? And what? And nothing else, no. Nitrite is here. This is nitrous acid, right? Not the same thing, because they have not ionized on the product reactant side. So the total NIE is this guy. OH minus plus nitrous acid yields NO2 1 minus plus H2O liquid. Okay, of this reaction, if I asked you to label the acid base, conjugate acid, conjugate base from your video last night, what would you label down here on the NIEs? Of these 2, which is acting as the acid? Right, because you can see that it's a bad acid, right? They've donated, so this is an acid. This has to be the base, and that's kind of like the, because you can see the differences, and you see OH. So then this makes what? What do you label this? Conjugate base, right? Acids make conjugate bases. Bases make conjugate acid. And why is this considered a conjugate acid? Yes, and it can, if you in the reverse direction, you could have H2O donate the H plus to the nitrite, and then make the 2 products on that side. So that's why it's conjugate, because if you go reverse, it acts in the different opposite fashion. All right, Next one. This one I think I actually had on the video. No, I didn't. Okay. Hydrofluoric acid plus ammonia. How do you think it reacts? Ammonium. So we see this H is donating itself to NH3 to make NH4 plus, and then what's left over? The fluoride, right? And this is all an aqueous solution, so they do make ions. So this does make ammonium fluoride, but ammonium with anything is always soluble because it's kind of related to group 1 metals. They're always soluble. So I actually went ahead and wrote it as a soluble product here. This is a weak acid, you can't touch it. This is a weak base, can't touch it. This is the product. This is the NIE. Okay, there's no ionization needed to happen on the reactant side. Okay.
So if it's either a base or an acid, you can't touch it.
It's a weak base, weak acid. It's the weakness of it that indicates it does not ionize. Because up here, this was a base, right? This is a strong base, but strong base is 100% ionized, so that's what we had to separate it. So it's all about the weakness or the strength of it. Let's do 4, and then I'll pick and choose from here, okay? Do 4. Tell me what it is. So acetic acid plus HCN, because you're saying this is a plus, that's a minus, that's a plus, that's a minus. You're double are you replacing? Sodium acetate. Okay. Tell me what's ionized. That's a weak acid, right? Weak acid, leave it alone. HC2H3O2. Okay, soluble salt specifically, right? So what happens? It does ionize Na plus and CN1 minus. Okay, so I'm going to put SS above that soluble salt, so it does ionize. This one? Weak acid, so don't touch this. Okay, keep going. Soluble salt, because it's a group 1 metal. Sodium, ion, and acetate. Okay, spectators? And that's it. So the NIE is acetic acid plus cyanide ion yields hydrogen cyanide or cyanic acid and acetic ion. I'm not going to rewrite the NIE, you guys can assume. So that's where the weak acids and weak bases really come into play here. Who is the acid, the best acid in this reaction? This or this? It's not a trick question, promise. Acetic acid, because it has the H, correct? And you can see that it donated it to the CN minus in the products over here. So this would be acid base, this would be conjugate acid, conjugate base. Okay, let's do this number 6. This one has to deal with some terms that they can include in our NIE, in our reactions based off the stoichiometry of it. So if they say something called equimolar, I think this was at the minute 22 on the video last night. Equimolar means same number of moles of each reactant. And so sometimes that's a problem because if you have, let's say, a diprotic acid, how many protons or how many H's are there to be neutralized? 2. Diprotic, like H2SO4, has 2 H's to be neutralized. But let's say you have 1 mole of sulfuric acid and 1 mole of sodium hydroxide. 1 mole of sodium hydroxide is only going to neutralize one of those H's. So that leaves behind an H, and that's where we get that whole H plus and then HSO4 1 minus. And so the equimolar part is important. This one's not equimolar, this one's actually giving us the stoichiometry. So we have a ratio of phosphoric acid, we have 1 mole of that, and 2 moles of sodium hydroxide. Okay, so I have 2 moles of this. And I'm not going to write out the coefficient specifically, but you'll see it actually does transfer to be that. So this right here means I have 2 hydroxides. 2 hydroxides will only be able to neutralize 2 of those. So what's left over here? What's the full anion? HPO4. Because 2 of those H's are getting neutralized, so it leaves HPO4. So that HPO4 combines with sodium to make sodium HPO4. But what is the charge of HPO4? 2 minus, right? So it's that right there. Crisscross it down. So that's the fact that there's 2 moles of the OHs that neutralize only 2 of those H's, leaving 1 attached. It kind of changes the anion to be HPO4 2 minus, and then how many waters were created? Based off that knowledge that you said 2 OHs, 2 waters were created. Okay, so then now you can kind of go back and see that the 2 sodiums, this does make a coefficient of 2 here, and this does make a coefficient of 1 there. Okay, so then here, what's NIE? This is what? Weak acid, so you can't do anything, correct? So this stays the same. This, okay, so 2 Na pluses, because remember the coefficient does apply. I mean, you make 2 of those and 2 of those. Strong base, it ionizes, continue. Okay, so it's a group 1 metal, so it makes 2 sodium ions, because that's subscript of 2, and then plus this weird thing, HPO4 2 minus, and 2 aquas. Okay, so what's the only spectator? Sodium. So then you get phosphoric acid plus 2 OHs, 2 OH minuses, yields hydrogen phosphate and 2 waters. A little complicated on that one because you have the reactions with geometry given to you. Okay, if I go to 7 through 10, you tell me which ones that you think I should do. I want to do like 1, 2 more. Which one do you feel you can't do? When it says bubbled, the only indication here is when this says bubbled, this means it's HCl gas, not HCl aqueous. So can you ionize a gas? It's going to stay gas.
Are you on the homework sheet?
This, I'm not on the homework sheet right now. I'm just asking you guys which one I can do right now for acid-base still. 8? Okay. Copper 2 oxide solid. Okay, so this word solid is incredibly important because copper 2 oxide actually is insoluble anyway, but if it was like, I don't know, solid sodium hydroxide, that solid indicates that you cannot ionize it. Because remember I told you before, like, oh, if I don't tell you the state of matter, assume it's aqueous. This is legit solid, so you have to write solid here for yourself so you do not ionize it. Dissolved by hydrochloric acid. Okay, what does that reaction come to be? Take a stab at it. Copper what chloride? Copper 2 chloride and water. Okay, because I know you're seeing just an O and just an H left over, but we don't just make hydroxides by themselves. They always combine with something else usually, so it's going to make water. And I'll show you that the stoichiometry, the balancing does work out this way. So you see the 2 chlorides, you need 2 there, so then we have 2 H's and O, H2O. So it does work out. Okay, that's a solid. This is aqueous, because I told you to assume. This is also a strong acid, so that's going to ionize. This, soluble or not? It's soluble. Okay, halides are all soluble except for some of those heavy metals. So this is soluble salt, and this is pure liquid, so we leave it. So this stays. This ionizes 2H pluses plus 2 Cl minuses, yields this thing that ionizes, Cu2 plus 2 Cl minuses plus pure liquid water. Okay, so the only spectators, 2 Cl minuses. So it's copper 2 oxide plus 2H pluses yields copper 2 and water. What color is this solution? Blue. How do you know? Copper 2 is blue. It's just copper 2 ion in water, so that's the only thing that's there, so it's a blue solution. Okay. Look at your 30 NIEs. It's in your packet. What is it? I'm pretty sure it just says 30 NIEs in the top. And no, it says AP chemistry practice with NIEs and predicting products without redox. And it's got little questions underneath. Or if you see 1 through 30. You see that? 1 through 30 is on the page next to what? It's on the back of the... Oh, I'm sorry. Somehow I just got that. It's on this little staple packet, and it's like, it goes from here to here. I'm sorry I did not talk about the same page. Here to here. Okay, So that is what you're going to do with a partner soon. Before you start that, though, I'd like for you to check what you need to on reaction to 22 NIEs so that you can clarify misconceptions before you proceed. Okay? So I'm going to pass these out, these keys, and then ask away. And then I'll just go through some.
How do you do
That's just one problem.
combustion?
How do I do it NIE combustion?
Yeah.
It does not have NIE.
You just don't write one.
I don't know that. Yeah, you just write the NIE, you write the BCU directly as it is, and there's no NIE for it. That's number 2 on the thing on 22 NIEs. Yeah, I'll get you one second. So just share the key with the person next to you because I currently printed 10 of these. So the 22 NIEs is something you can quickly look at because you should have done those last night. And I'll answer whatever questions I need.